All right, number 15. All right, so this one is z cubed minus 125. Okay. This is factor the difference of cubes. All right, so this one's going to be set up like this. If you have a hard time remembering this, it might be a good idea as soon as you get the final to just recopy it from your memory. Try to memorize this. I'm not sure if an instructor will just give this to you, but typically they want you to remember it. So this is going to simplify into a minus b, so we take the cube root of each one of these, and then this is a squared. We switch signs from what we had, and it's ab plus b squared at the end. Right? So cube root of z cubed is going to be z, right? And then the cube root of 125 is going to be 5, or negative 5, right? Negative 5 times negative 5 equals 25 times another negative 25, or positive 25, and times another negative 5 equals a negative 125. All right, so we're going to square our first term, which gives us z squared. We're going to multiply our two terms times each other, so we get a 5z. I know on this one it seems like we'd get a negative z, but we always use this as our guideline for it. Okay, we always do the opposite of what we did on the first one. And then we're going to end with 5 times 5, which is 25. Once again, we're kind of ignoring those. Well, negative 5 times negative 5 does give you 25. But there we go. Number 16. We got 27t to the third, t cubed, minus 8. And we're doing, plus 8. So now we're doing sum of cubes again. Remember, this is a cubed plus b cubed. Right? That's the format it's doing. So this one's going to be a plus b. And remember, we're doing the same sign. And we're going to go a squared. And that's an opposite sign, right? You can see that we did same opposite as here as well. So a b plus b cubed. Okay? And we always end with addition. Okay? Same opposite add. That's always the way this thing goes. Now, our cube root of 27t cubed is going to be 3t, right? And then our cube root of 8 is 2, right? 2 times 2 times 2 is 8. Now 3t, right, we're squaring this first term, 3t times 3t is going to be a 9t squared, right? And we multiply these times each other to get our second one. We're going to minus, so this is going to be 6t, right? And then we're going to do the last one, multiply by itself. So b squared is 2 squared, which is 4. And that's what we get on there. Okay. Number 17, solve the equation. Okay. We get w squared minus 12w plus 11 equals 0. Okay. Now we've learned all kinds of different tools to solve this. I mean, we could use finding the linear factors. We could do completing the square. We can do the quadratic equation. That's what we've kind of spent this whole semester doing, is really figuring out all the different ways we could solve these things. But really the easiest thing to do would be to just split these into linear factors. Okay. We'll probably have plenty of chances to do the quadratic equation, even completing the square, but this one, we'll just do this one. Now, we're looking for numbers that add to be, or multiply to be 11, and add to be negative 12, right? Now, if it's going to add to be this negative, right, but multiplied to be a positive, we know that we're going to use two negatives, right? We're going to lead with W's, and we know that 1 and 11 can equal that, right? Negative 1 and negative 11 can equal a positive 11, and the negative 11 and the negative 1 can add to be 12, so that's going to be our answer for this. This equals 0. Now, to solve this, we use the concept of something times something else equals 0, right? So one of these has to equal 0. So either W minus 1 has to equal 0, or W minus 11 has to equal 0, right? So one of these has to be our answer. So once we solve this equation, we add 1 over here, and find out that W equals 1. And then we add 11, and add 11 over here, and find out this one is W equals 11. Right? So our answers to this, our solutions that we have in our solution set is 1 and 11. Okay? You could also write this as W equals 1, 11. I don't think they'll accept that, but I like to put them in a solution set. Alright, so 18, we got t squared minus 4t equals negative 3. You know what, just for the fun of it, let's, well, let's keep you doing it simple. Okay, I don't want you to overcomplicate it. But what we're going to do is add that 3 back on to this side. That way it's set equal to 0, just like our first one that we just did was. So this is t squared minus 4t plus 3 equals 0. These cancel away on this side, right? Now we're looking for something that multiplies to be positive 3 and adds to be negative 4. Once again, if we got a negative in our middle term, just like we had on this one, and a positive on our last term, these terms, or these linear expressions, are both going to be negatives. Alright, we're going to lead with a t. T times t equals t squared, right? But this is going to be a 3 and a 1, right? Because negative 3 times negative 1 equals a positive 3, and negative 3 plus and negative 1 gives you a negative 4. So once again, we solve these that same way. So t minus 3 equals 0, and t minus 1 equals 0. Once we do the math on that, we're adding 3 to both sides. T equals 3. And add 1 to both sides here. And t equals 1. Okay. Number 19. We got 121 S. Hang on, I didn't put my solution set for that. That's 1 and 3, right? That's what you want to put in your blank here. Okay. 121 S squared equals 81. Okay. So on this one, I'm going to bring this over, right? And so we're going to get 121. You know what? Let's do this one a different way, because I think you're probably used to doing it. You just got done doing it this way, but typically what we're doing is we could divide this 121 away from both sides, right? So instead of moving that over and finding the difference of squares, which would still lead us back to the same answer, and you're welcome to try that, but I kind of want you to do this. That way it would just be simpler for you. So this is S squared equals 81 over 121. Okay? And so to solve this, we're going to take the square root of both these. Now we take the square root of that one. This is going to give us the plus and the negative version of this. And we're looking for the square root of these, right? And we do have a perfect square root of both those, right? So these are going to eliminate, right? And s is going to equal plus or minus, and then the square root of 81 is 9, and the square root of 121 is 11. So this is going to be both the positive and the negative version of 9 over 11. If we want to write it out, we get negative 9 over 11 and 9 over 11. And that's our answer for that one. Okay. All right. Number 20. We have, here's s plus 2, and s plus 4 equals 24. All right, so what we're going to have to do is factor these back out, and then we'll move on from there. Well, let's do that first. So s times s is s squared, right? And then s times 4s is 4s, right? And then 2 times s is 2s. And then 2 times 4 is 8. And this still equals 24. Okay? Now we can combine our like terms here. 4s and 2s, which gives us a 6s. So we got s squared plus 8 equals 24. So then what we have to do is we have to minus our 24 and set this thing equal to 0. Now we get s squared plus 6s equals minus 16 and equals 0. And then we're thinking about things that multiply to give us a positive 6, but a negative 16. Now, when we're looking at this, we know that it's going to give, when we have a negative product, we know that that's created by a negative and a positive number, right? A negative times a positive equals a negative. And then we know our s's are going to be in the front here. We're thinking about what these numbers could be. Well, negative 16, factors of it are 1 and 16, remember? And our smaller number is going to be the negative on this term because we get a positive sum, right? Well, we got negative 2 and 8, right? And we found it, right? That fast. Well, the only other one we would have was 4 and 4, and that just clears away, right? So we're going to have a negative 2 and a negative 8, right? And if we're solving for this, s minus 2 equals 0, which we'll find s equals 2 once we add it to both sides. And then s plus 8 equals 0. If we subtract it from both sides, we're going to find that s equals negative 8. Okay? I did kind of skip a step, but I've been doing them before, and you could look back on one of the earlier ones to see how to do those at the end, or end game. All right, 21. All right. Well, I don't have to redraw it. We have it right here. What we're going to be using on this one, it says find the length of the hypotenuse of the right triangle. The triangle is not necessarily drawn to scale. In fact, it's almost certainly not. But what we're going to be using is the Pythagorean theorem, right? We got a squared plus b squared equals our c squared, right? Now on this, we have to use these as one of our a's and b's, and always our hypotenuse is going to be our c squared, right? So let's use this as our a, this is going to be our b, and that's going to be our c. So our a is x minus 2, right? And then we need to square it, right? That's part of our Pythagorean theorem. So we're going to add it to our b, which is this 2x minus 14, and I'm going to square it just like we did with that one. And then we're doing our x is our c, right? And we need to square that one as well. Alright, so now we need to completely factor this. Now we did this the fast way together, so we're going to do it this same way. So what we do is when we're squaring this, we do x times x, which is x squared. And then remember, this is going to be x minus 2, and then x minus 2, right? So we're really foiling this, but we're going to do it the fast way. So negative 2 times x is negative 2x, and then we double it. So it's going to be a negative 4x, right? And then we're going to do negative times negative 2, which is a positive 4, plus, and then 2x times 2x is 4x squared, and then 2x times negative 14 is going to be a negative 28x, and then we're going to double that, which is a negative 56x, right? And then we're going to do negative 14 times negative 14, which is a positive 196, I think. Let me just double check that. Yeah, positive 196, and that equals x squared. Now, once I start manipulating these around, I know I'm going to minus this x squared and minus this x squared, so these are really going to eliminate. So I can already kind of set it up for 0. I'm just going to do that real fast now. I'm going to do my 4x squared first. I don't have any other x's since I eliminated those. But now I'm going to combine this negative 4x with this negative 56x, which is going to give me a negative 60x, right? And then this positive 4 with this positive 196, that gives me positive 200, right? And this equals 0 now, right? So now, look at this. And remember, our first step when we have these is to try to divide our greatest common factor out, right? And all these can be divided by 4. Let's divide everything by 4. We really don't have to take it out on the outside because we're dividing everything by it, right? And even moving it over here, so it just goes away. We could factor back out and then divide by 4 on both sides, but 0 divided by 4 is 0, right? So that's why our 4 just goes away. So we just get x squared minus 15x, and then 200 divided by 4 is going to be 50, right? And that equals 0. Now once again, we're looking for something that multiplies to give us positive 50. Right? We can go down this list, 1 to 50. Eventually we're going to end up at 5 and 10. Now they both have to be negatives for that to be a positive product and a negative sum, right? And these work out. So this is going to be x minus 5 and x minus 10. Is that 0? If we solve this out, we're going to do x minus 5 equals 0. Add 5 to both sides, and we're going to find out that x equals 5. Same thing over here, x minus 10 equals 0. Add 10 to both sides, and x equals 10, right? And now it both looks like these could be solutions, right? So it's like you're thinking, well, is this going to be 5 or 10? Well, once we start plugging things in, one of these is probably going to disqualify itself, okay? Now, if we take this smaller one and we put it in, it kind of works for these, but once we get to this and we did 2x minus 14, so we did 2, and then we said x was 5, right, minus 14, okay, this would be 10 minus 14, right? Minus 14 equals negative 4. And that can't be our answer. We can't have a negative measurement. We'd never do that, right? So we have to use the 10. Okay? So we plug that in. So this one's going to equal 10, right? And then that 10 minus 2, that one's going to equal 8, right? Now we can do this one. So 2 times 10 minus 14, well, that's 20 minus 14. And so our other one's going to equal 6. And if we plugged in all these numbers, we'd get 8 squared, which is 64, plus our 6 squared, which is 36. 64 plus 36 is 100, and that's equal to our 10 squared, which is 100 as well. So everything works out. So just be sure to plug them back into your Pythagorean theorem and just make sure everything works out for your test. All right, number 22. That's 7 over 6y squared plus 3 over 8y. Okay. Now, to be able to add any fractions, we have to have a least common denominator, right? And it's what we can multiply these things up to where they're going to be the same, right? Now we know that the first number we multiply up, when we keep doing this, you can do this any way you'd like. There's multiple ways to do it, but the first number we're going to find that we're going to come across is 24, okay? Because we go 6, 12, 18, and then 24. This one's 8, 16, and then 24, right? So we both end up at 24. That's our least common one when we're doing those multiples. Now this one, we can if we just added a y to this one, this would be equal with our y. So we're going to need to use that y squared, because we're going to have to be able to add another y to this one. Now, what we do is we try to get these to be that, right? So this is going to be 24y squared on this one, and then we're going to have a 24y squared on this one. Now to get this to be this 24y squared, we had to multiply this times 4, which is what we have to multiply this time. So 7 times 4 is 28. To get 8y to be 24y squared, we're going to have to multiply this one times a 3y, which is what we have to multiply this one times, a 3y. So 3y, or 3 times 3y is going to be a 9y. And really we can just write this expression with these two bottoms, just we can add this where it's just 24y squared on bottom, right? Just have, it keeps the same denominator. But we can't really add these, so we can just put this as, and typically put this in front of that. So let's put 9y in front of that 28. We're just going to use our commutative property to just switch our expression around, right? There. Can't help but do those lines for those that have worked with me in lab. I'm just worried about this running together is really what I'm worried about. Not being able to see. Alright, so our next one, once again, we're adding or subtracting fractions, so we're going to have to find a least common denominator on this one. And this really is a tough skill for a lot of people. It's not a tough skill for you, then consider yourself lucky, right? But one thing we know with this is the difference of squares. So this thing is going to break apart, right? This is going to break into x plus 8 and x And now this one already has an x plus 8, so our least common denominator for this one has to be what this is. So it's x plus 8, x minus 8. Now this one already has both those terms, so we don't have to spend a good bit of time really fiddling with that. But so this one isn't really going to change. The only thing we're really going to have to do, I'll get to that in here in a second. Let me focus on this first. But this one already has the x plus 8, so really what this needs is an x plus x minus 8 on bottom. And whatever we put on bottom, we have to put on top as well. Okay. So we're going to distribute this. This becomes x squared minus 8x. Okay. And now our least common denominator makes it to where we don't really have to add anything to this. We just have to distribute our negative to each one of these. Right? So this is going to become minus 3, and then this negative causes this one to flip. So this is going to be plus x squared. And this is all over x plus 8, x minus 8. If you wanted to make it still be this, I don't think that you'd have a professor that would care, but I like to keep it separate just in case there's something that ends up where we can eliminate it. So we can combine our x's here. We get 2x squared, some work to do, and then minus 8x, and then minus 3. And this is all over x plus 8, x minus 8. And just to double check and make sure that we can't do much more with this, we want to try to multiply this and see if this comes out to be 6. And it doesn't look like it's going to end up in a perfect linear factor because there's nothing that we're going to be able to add to get this negative 8. So I believe this is what we're looking at for this final answer. Doesn't look like it splits in anything else. All right. And I think on his answer he did, in the review you're looking at, he wrote this is the answer. So either one of these works. I don't think you'll have an instructor that's going to lose his mind if you put in either one of those. Both of them are correct. All right, last one. 24, well, at least for this page, 25x to the 8th. And y to the 4th over 24. And this is over 35x to the 5th. Y to the 8th over 8. Now anytime we're doing fractions, this is really just a division problem. Okay? So we can actually rewrite this as 25x to the 8th, y to the 4th over 24 divided by 35x to the 5th, y to the 8th over 8. Okay? Now anytime we're dividing fractions like this, we switch it, right? Keep change flip is what they say. So we keep this the same. And this is still 25x to the 8th power, y to the 4th power over 24. We're going to change our sign to multiplication, right? And then we're going to flip this fraction. This 8 goes to the top. And then we get 35x to the 5th, y to the 8th. Right? So let me do this too. I don't normally do this in lab, but I think this is going to help keep this thing simple. Okay. So now we got a 24 and an 8 here, right? And so what we can do is we can reduce these together before we multiply them. So instead of multiplying straight across, we're going to reduce them here. We can divide both sides by 8. 8 divided by 8 is 1. 24 divided by 8 is 3. Right? We can reduce these two numbers together. We can divide them both by 5. 25 divided by 5 is 5. 35 divided by 5 is 7. Go ahead and put these. 5 here. We got 3 here. We got 1 here. We got 7 here. Okay. Now we're going to start reducing these, right? Basically what we can do is we can take away an x for an x, or we can take away 5 x's here and take away 5 x's here. That leaves us with x to the third. We can take away 4 of these y's here, and we can take 4 y's away here. That leaves us with y to the fourth here. And now we're ready to finish this thing off. We're really just going to multiply straight across, and we really won't have, if we've reduced before we multiply, we won't have anything to reduce at the end of this. We've reduced correctly and caught all of them. Okay, so 5x cubed times 1 is 5x cubed, right? And then 3 times 7 is 21, and then we just have our y to the fourth. And that finishes up our page 2.